This is SpaceTime, Series 23, Episode 101. Coming up on SpaceTime, evidence suggests that somewhere out there, in the distant past, was a very different type of supernova. New data shows the Saturnian ice moon Enceladus has been resurfacing its frozen crust. And another near miss for China's toxic space program. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that an unusual fast-spinning, highly magnetic type of supernovae in the early universe may have been responsible for creating some of the heaviest naturally occurring elements on the periodic table. The findings, reported in the Astrophysical Journal, would help explain why colliding neutron stars can't account for the amounts of these heavy elements being found. The new research also reveals that current models can't explain the amount of gold in the cosmos, thereby creating an astronomical mystery. The study has already resulted in a new-look periodic table showing the stellar origins of naturally occurring elements from carbon through to uranium. Okay, time for a bit of background. All the hydrogen in the universe, including every single atom of it on Earth today, was created in the Big Bang 13.8 billion years ago, which also produced a lot of the helium and lithium, but not much else. The rest of the naturally occurring elements were made by different nuclear processes happening inside stars. Mass governs exactly which elements are forged, but they're all released into space in the star's final moments, either explosively in supernova events in the case of massive stars, or as dense outflows similar to the solar wind for low-mass stars like the Sun. One of the study's authors, Associate Professor Amanda Karakis from Monash University and Astro 3D, says astronomers think of stars as giant pressure cookers, where new elements are created under extreme temperatures and pressure. The nuclear fusion processes which make these elements also provide the energy that keeps stars shining bright for millions to billions of years. During their lives, stars shine by fusing hydrogen in their core into helium. And once they run out of core hydrogen, they'll contract. That increases core pressure and temperature, and that allows them to begin fusing helium into carbon and oxygen. Now, for relatively low-mass stars, like our Sun for example, that's pretty well where the process is going to end. The star, which by now has expanded and cooled into a red giant, loses its outer gaseous envelope, which detaches and floats away as a planetary nebula. What's left behind is its white-hot stellar core, a white dwarf which will slowly cool over the eons of time. However, more massive stars can go on to fuse carbon and oxygen into progressively heavier and heavier elements until ultimately they produce a core of nickel and iron. But no matter how massive a star is, once it begins producing iron in its core, the nuclear fusion process quickly breaks down, and the balancing act of hydrostatic equilibrium between the outwards push of energy from nuclear fusion and the inwards push of gravity ceases, and gravity wins. And this causes the star to collapse in on itself in a core collapse supernova, an explosion so bright it can briefly outshine an entire galaxy. Usually a core collapse supernova results in the production of a super-dense compact object called a neutron star, and if the progenitor star has enough mass, a stellar mass black hole. It's thought the extreme energy of a supernova explosion can produce most of the remaining elements on the periodic table. However, for some of the most massive elements, not even a core collapse supernova could be powerful enough. They're thought to be forged together through a different, more extreme method involving the collision or merger of two neutron stars. In fact, by some estimates, half of all elements that are heavier than iron, such as thorium and uranium for example, were thought to be made through this process. And that's where our new study comes in. A fresh analysis by Karakis and colleagues reveals that the role of merging neutron stars may well have been considerably overestimated, and that another stellar process altogether would be responsible for making most of the heavy elements. Put simply, neutron star mergers didn't produce enough heavy elements in the early life of the universe, and they still don't now, 13.8 billion years later. Cracker says the universe simply didn't make them fast enough to account for their presence in very ancient stars, and overall there aren't enough neutron star collisions occurring now to account for the abundance of these elements today. Instead, the authors hypothesized that heavy elements needed to be created through an entirely different sort of stellar phenomenon, an unusual type of supernovae that collapses while spinning extremely fast and generating very strong magnetic fields. The research is the first to calculate the stellar origins of all naturally occurring elements, from carbon right through to uranium, from first principles. That means the new modelling will substantially change the presently accepted hypothesis of how the universe evolved. Still, there are some issues which remain unresolved. For example, the new model tries to explain the origins of all the elements at once. Trouble is, it results in an overproduction of silver and underproduction of gold compared to observations. And that means there's got to be yet another type of stellar explosion or nuclear reaction to account for the real observations. Overall, this paper refines previous studies that have calculated the relative roles of stellar mass, age and arrangement in the production of elements. For instance, the researchers established that stars smaller than about 8 times the mass of the Sun produce carbon, nitrogen and fluorine, as well as half of all the elements heavier than iron. Or stars more than 8 solar masses produce many of the elements from carbon through to iron, including most of the oxygen and calcium, 2 of the key elements needed for life as we know it. The authors show that apart from hydrogen, there is no single element that can be produced only by one type of star. For example, half of all the carbon in the universe is produced by dying low-mass stars like the Sun, but the other half will come from supernovae. And half of all the iron comes from core-collapsed supernovae, but the other half will come from a different type, thermonuclear supernovae. They happen when a white dwarf explodes after drawing off too much material from a close-orbiting binary companion star. Pairs of massive stars bound by gravity, in contrast, can transform into neutron stars. And when these smash into each other, the impact produces some of the heaviest elements in nature, including gold. But on the new modelling, those numbers still don't add up. Cracker says that even the most optimistic estimates of neutron star collision frequency simply can't account for the sheer abundance of these elements in the universe.
One thing that we found with this study is that most elements have a contribution for many types of stars. And so we looked at the different types of stars that make elements over their lifetime. And these include dying low-mass stars, very much like our Sun, at the end of its life. We also looked at exploding massive stars. So these are stars that die as supernova explosions. They also make many elements. And then we looked at also, sometimes they're considered rare objects, but what happens when the embers of stars, and these are white dwarfs or neutron stars, what happens when they merge? And we took the results of those sort of calculations and we found they also make elements, and we added that into our calculations as well.
But you were finding that the original theories that, there's got to be lots of neutron star collisions to make the heavy elements that we thought existed, that's not what you're seeing.
Well, yeah, so that comes down to the puzzle. So half of the elements heavier than iron, they're created, so all of them are created by essentially neutron addition onto, for example, iron. So let's say you have something where neutrons are produced. You might start with iron or nickel or something, and it captures neutrons, and you can make heavy elements that way. And the idea was that half of those, and we think that there are 2 sites of neutron capture production in stars. One occurs under slow conditions. This is the slow neutron capture process, and we think we have a good handle of where that comes from. This is dying low-mass stars. But the other half comes from, well, it's called the rapid process. It's a rapid neutron capture process. And we don't quite, and for a long time it was just hypothesized. So we knew that this rapid process must happen, but we didn't know where. And so it was a huge mystery. And in 2017, we, through the combination of LIGO and the follow-up with telescopes, we found evidence that, first of all, neutron star mergers actually occur in nature. And we found evidence that, yeah, that's right. Yeah, exactly. And then we also found that they make heavy elements. And that was amazing because finally we have a confirmed site of this rapid process. But the thing is, it was always the question where this rapid process happened. So neutron star mergers were just one of the sites, but it was always thought, well, maybe for various reasons, it must also occur in core-collapsed supernova, in massive stars that explode. But the massive star calculations didn't really support that. So the predictions didn't really hold up that end of the bargain, basically. But the neutron star mergers, we were like, well, if they happen, they're going to make so many of these heavy elements. And then we found evidence that they do. And we thought, we've solved that mystery. We know where this rapid process happens in nature. It must be neutron star mergers. This was 2017. And then we come along and we take the predictions from neutron star merger calculations and we put it into our model and we go, okay, this is surprising. We can't make enough of them. And this was really, I think, it was, I guess, one of the exciting things that came out of our results. Well, we're very ambivalent about where the rapid process happens. We're just interested in trying to explain the origin of elements. So we weren't invested either way. And we found out, we thought, well, hang on, it's really surprising what's going on here. And so we looked at all the uncertainties that affect these neutron star merger calculations. And within the bounds of what's accepted reasonable at this time, we couldn't change the results to make more of these rapid neutron capture elements within the timescale needed. And this is really still, I think, where we left our study. And so obviously there's many uncertainties and many mysteries still yet to solve here. But yeah, but that was really the exciting thing that we think that we found.
So explain to us what a very rapidly spinning supernova collapse is, one that generates strong magnetic fields.
Yeah, so it's just a different type of, so massive stars, when they die, they essentially they collapse inwards and then they release a lot of, and then materials expelled out and they release a lot of elements. That's the garden variety supernova, and that they make a lot of oxygen and magnesium and silicon. Most of these elements in the periodic table, they come from these garden variety massive star explosions.
This is the onion unpeeling.
This is the onion unpeeling. That's a great analogy, the onion unpeeling. We think that at the release of the beginnings of the universe, the massive stars that formed, they were really compact and they were spinning really fast. If they're spinning fast and they have convection currents inside them, they can generate really strong magnetic fields. And we think that these are just still hypothesized, and they're hypothesized to explain various observations. And
so are you talking about population 3 stars exploding? Is that what?
Yeah, but not all past. Yeah, so population 3, so the first generation. So these could have been some of this, but we also think maybe also it could have also be just really compact, very fast spinning population 2. So also ancient, old and what we call metal poor, so that it weren't born with many heavy elements.
Yep.
But so we think that it could have even been some of that, but they just need to be spinning fast. They generate strong magnetic fields, and the combination of that, when they explode, they produce conditions that are ripe for this rapid neutron capture process, in contrast to the garden variety supernovas that aren't spinning so fast and don't have these magnetic fields.
We can't see that process anymore.
Well, we think so. There's one class of gamma ray bursts which we think are the result of maybe some of these, but we see them at such great distances. They're many megaparsecs away or further. They're in the early universe, we think. So when we're looking back in time, this light takes time to reach us, and we think we're seeing them when they were 10 billion years ago. So we don't think many of them happen in what we call our local universe. So not many of them nowish.
Yeah.
If nowish is a term that probably encompasses even 2 billion years.
That's as scientific as it needs to be, I think.
That's right.
Is this something that James Webb will be able to see? Because it'll be sort of looking back towards those really early eras and hopefully finding things that we can't sort of see now anymore.
Will James Webb see them more? I'm not sure about James Webb. Maybe the Vera Rubin telescope will. So these are transient events. So these are events that essentially go bang in the night, and you have to be searching the sky all the time. So you have to be essentially just have a telescope open all the time on the night sky, looking at everything that goes bang, and also surveying the same patch of sky over and over and over again to find what we call these transient events. So James Webb's also looking in the infrared, so it's looking in the longer wavelength. Actually, I'm not sure how much light these gamma ray bursts or these really unusual supernova release in the infrared. They might maybe see something about their end products or the afterglows of them, but to actually find more of them, we probably need something like gamma ray telescopes and the Vera Rubin, which will come online soon.
So basically what we've got here, we've got a different way of looking at how the elements on the periodic table came about. Am I right to say it's not that different? It's just looking at refining some areas of it?
Yeah, so these elements that we think are that formed, so these elements heavier than iron. So we think that they're still formed through, essentially half of them formed through the slow neutron capture process, this slow process, and the other half through the rapid process. So that hasn't changed. And even elements such as europium or gold, we think they're still predominantly made through the rapid process. That hasn't changed. But I think what changed with our study is which of the rapid process events makes most of these elements. And that was really the thing that's changed, because the idea was, as I said, in 2017 onwards, well, all those rapid process elements must be made in merging neutron stars. And what we've changed is where we think those elements actually form. We think that some elements, like antimony is one strange element that seems to be still predominantly made in emerging neutron stars, but elements like gold and silver, well, we think they're mostly made in these unusual supernova, these rapidly rotating supernova.
That's Associate Professor Amanda Krakis from Monash University and Astro3D, the AIC Centre of Excellence for All-Sky Astrophysics in 3 dimensions. And this is Space Time. I'm Stuart Gary. Still to come. New data suggests the northern hemisphere of Saturn's ice moon Enceladus has recently been resurfacing itself with material from the frozen world's interior. And another close call for China's toxic space program. All that and more still to come on Space Time. New data suggests the northern hemisphere of Saturn's ice moon Enceladus has recently been resurfacing itself with material from the frozen world's interior. The findings, reported in the journal Icarus, are based on new composite infrared images taken by NASA's Cassini spacecraft. The images are the most detailed global views ever produced of the 500-kilometre wide moon, and they provide strong evidence that it has been resurfaced with ice from its interior. The images were obtained by Cassini's visible and infrared mapping spectrometer. Launched from Cape Canaveral in Florida in 1997, Cassini arrived at the Saturnian system in 2004, studying the ring world and its many moons until 2017. The spectrometer separated the light into its various wavelengths, and that information tells scientists about the composition of the material reflecting the light. The spectroscopic data, combined with detailed images captured by Cassini's imaging science subsystem, were then used to make new global spectral maps of Enceladus. Back in 2005, Cassini scientists discovered that Enceladus was ejecting enormous plumes of water ice grains and vapor into space. The jets were shooting up from a 10-kilometre deep global subsurface ocean buried under the moon's icy crust. These cryovolcanoes, or geysers, are located in deep rifts known as tiger stripes around the moon's south pole. There's so much material being spewed into space from these tiger stripes that it forms Saturn's E-ring, and there's enough left over to rain back, or should I say snow back, down onto the surface of Enceladus, keeping it covered in fresh, clean ice. In the process, making it one of the most reflective bodies in the solar system, looking a lot like a highly reflective, bright white snowball. Things got even more interesting in 2018 when scientists reported the detection of complex macromolecular organics in Enceladus's jet plumes, indicating potential hydrothermal activity on the moon's seafloor driving complex chemistry. In other words, something very similar to the mid-ocean ridge hydrothermal vents we find on Earth's ocean floor, and which are teeming with life and may even be a point of origin for life on Earth. The new spectral map of the Enceladian surface clearly shows infrared signatures that correlate with the geyser activity at the South Pole. But interestingly, some of the same sorts of infrared signatures are appearing in the Enceladian northern hemisphere as well. That tells scientists not only that the northern area is covered in fresh ice, but that some kind of geological activity, a resurfacing of the landscape, has occurred in both hemispheres. The resurfacing of the north may be due either to icy jets or a more gradual movement of ice through fractures in the crust from the subsurface ocean beneath. One of the study's authors, Gabriel Toby from the University of Nantes in France, says the infrared data shows that the surface at the South Pole is really young, which isn't a surprise. After all, astronomers have known about the jets which are blasting the icy material there for quite a while. But now, thanks to these new infrared images, researchers can go back in time and say that at least one large region in the northern hemisphere also appears to be quite young and was probably active not all that long ago in geologic time. This is Space Time. Still to come, another near miss for China's toxic space program. And later in the science report, a new study shows that California's wildfires have been increasing in intensity by about 10% per decade since at least 1984. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, Expressvpn, rated number 1 by Tech Radar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where Expressvpn can help you. Expressvpn's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
The dangers of China's decision to continue using highly toxic hydrazine fuel have been highlighted, with the first stage of a Long March 4B rocket crashing back to Earth next to a local school and blanketing the area in a poisonous orange cloud. Hydrazine fuel and nitrogen tetroxide oxidizer power most of China's rocket fleet, including both their Long March 2 and Long March 4 workhorses. But they're not alone. The Russians are also continuing to use hydrazine to power their Proton rockets, while the Americans continue to use the propellant once beyond the atmosphere. This latest Long March 4 launch from the Taiyuan Satellite Launch Center in northern China carried another remote sensing satellite into orbit. The Gaofeng 1102 is Beijing's 190th Earth observation satellite. It has sub-meter level resolution and will be used by the People's Liberation Army for reconnaissance and surveillance, although Beijing describes the satellite as being mainly used for land surveys, city planning, land rights confirmation, road network design, crop yield estimation, and disaster prevention and mitigation, as well as in support of China's Belt and Road projects. Meanwhile, another Chinese remote sensing satellite, the Jialing Gaofeng 02C, has failed to achieve its intended orbit. The satellite had been launched aboard a Kuaizhou 1A solid-fueled rocket from the Zhukwang Satellite Launch Center in northwestern China. Reports suggest the launch vehicle experienced technical difficulties during the ascent, preventing the satellite from reaching orbit. The 230-kilogram Jialing 1 Gaofeng 02C was designed to orbit at an altitude of 535 kilometers, providing images in full color resolution better than 0.75 meters and with a multispectral resolution better than 3.1 meters. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study shows that the wildfires which have been devastating California and the American West Coast have been increasing in severity by about 10% per decade since at least 1984. The findings by scientists from the University of California, Davis have been reported in the journal Environmental Research Letters and follow data from the European Space Agency's Copernicus Atmospheric Monitoring Service, which has found that the smoke from the West Coast fires has now reached Europe. Over the past month, dozens of wildfires have burnt vast swathes of land in California, Oregon and Washington state, killing more than 30 people and smothering the majority of the western United States in smoke. So far, some 2.7 million hectares or 6.7 million acres have been blackened and thousands of homes have been destroyed. The authors found the fires are much bigger and more severe during dry and hot years compared to their ferocity in other climatic conditions. Of course, for us here in Australia, it's a terrifying reminder of our Black Summer megafires, which began ironically about a year ago and weren't fully extinguished until May. The Australian fires killed at least 34 people and more than 3 billion animals, including many endangered species which were driven to extinction.
The Black Summer bushfires burnt out an estimated 18.6 million hectares. That's 46 million acres. It equates to 186,000 square kilometres or 72,000 square miles of land. The fires destroyed more than 5,900 buildings, including 2,779 homes. The fires drew between 300,000 and 900,000 tonnes of smoke into the stratosphere, more than any other fire ever recorded. This generated pyrocumulonimbus thunderclouds more than 1,000 kilometres wide, which reached altitudes of more than 31,000 metres or 102,000 feet, and ended up circling the entire planet. At the height of the Australian disaster, NASA estimated that more than 337 million tonnes of carbon dioxide was being pumped into the atmosphere. Scientists have raised concerns about early-phase clinical trial data from Russia's coronavirus vaccine. Moscow approved the so-called Sputnik V vaccine for widespread use despite not completing the usual Phase 3 trials, so they could lay claim to it being the world's first COVID-19 vaccine. But in an open letter to the Lancet Medical Journal, which published the original trial results early September, scientists pointed out that key values appear to have been duplicated, and they warned that the paper presents its results only as box plots without providing a detailed breakdown of the data on which the graphs are being based. The scientists behind the letter stressed that they're not alleging any scientific misconduct, but they are asking for clarification about how several identical, or at least similar, data points came about. In response, the study's lead author insists there were no errors in the results, and it did not intend responding to the open letter any further. The COVID-19 pandemic, which spread globally from its origins in Wuhan, China, has now killed more than 1 million people worldwide and infected more than 32 million others. Well, if you're one of those people who thinks going to the doctors only makes things worse, you'll be interested to know that a new study has found that some form of diagnostic error actually occurs in up to 1 in 7 clinical encounters, and in fact more than 80% of those cases are preventable. The findings, reported in the Medical Journal of Australia, shows that around 140,000 cases of diagnostic error occur in this country every year. These include 21,000 cases of serious harm, and between 2,000 and 4,000 deaths. Almost half of all malpractice claims against general practitioners involve diagnostic errors. To reduce these kinds of errors, the authors recommend several strategies, including group discussions and training, checklists, cognitive training to force doctors to show their thinking processes, and acknowledging and sharing their uncertainties. Well, if you suspect that Google was restricting the news it's giving you, you're right. A new study reported in the journal Nature checked out some 12.29 million responses to Google News searches across the United States. It found that unless you specifically search for an individual item, Google will only display results from a few pre-selected big national news companies. The authors found it almost never displays results from local news outlets. The results mean that local publications are missing out on desperately needed web traffic and advertising dollars. When Charles Darwin introduced the theory of evolution through natural selection 176 years ago, the study ignited a flurry of argument and debate which continues today. Despite overwhelming scientific evidence in paleontology, genetics, zoology, molecular biology and other fields all supporting evolution's truth beyond reasonable doubt, the faith of true believers remains strong. They lobby for creationist ideas such as intelligent design to be taught as alternatives to evolution in science classrooms. But now they're taking a new tact. Their latest attack plan is a leaf out of the playbook of the cancel culture movement. They're targeting Darwin directly, not over his science, but over his views about race. Views which are both wrong and completely unacceptable today and should be condemned, but which sadly were common in Darwin's days. Tim Mendham from Australian Skeptics says, in this case, they're targeting Darwin as a way to try and attack evolution theory.
What these creationists are saying, and some of them are actually good old Australian creationists who have moved to the US, what they're saying is that because Darwin's background, as a lot of people were in the Victorian days, it wasn't sort of squeaky clean, that all the statues to him should be taken down, and the whole concept of evolution should be wiped off the book because of his personality. Basically, they were suggesting that some of his theories, some of his suggestions were racist or racial profiling, etc. But by suggesting that, it doesn't invalidate evolution. It doesn't invalidate the work he did, because it's also been, of course, supported by many other people. Many. So, and it's pretty well established that it is, as you can in science, 100% or close enough to it, correct. But so therefore they're taking advantage of this particular cancelling culture to actually try and get statues of Darwin taken down and remove the teaching of evolution.
Who is Ken Ham and what's he calling on?
Ken Ham is an Australian. We have had the tendency to export creationists back to the US or to the US.
That'll teach them.
The trouble is we get anti-vaccinations, people coming here. I think we lose on the deal. There was a schism to a certain extent in the creationist movement in Australia way back when in the 80s and 90s, etc. And some of them left and moved across to the US, where, of course, there's quite a vibrant creationist movement.
Yeah, is he the dude that built a Noah's Ark?
He is, and the Creation Museum that beside it, he's been quite successful. He's quite an active person now, quite a major player in the creationist movement. Well, he wants the statues of Charles Darwin taken down because, according to him, Darwin's background, personal peccadillo statements that he made in the mid-1800s, even earlier than that, had racist tinges to them, perhaps even overtly racist, but that was the tenor of the time. He didn't implement that. He didn't do that. He didn't carry it into any activity. But because he might have said things or implied things, Ken Ham and other creationists want to take all the statues of Darwin down, but along with it want to have evolution removed from the teaching curriculum, etc. The fact that evolution exists but outside of Darwin, that there are other people who have done their research many times over and who support the evolutionary concept. Evolution exists whether you have Darwin or not. In fact, there were people well before Darwin who were promoting an evolutionary concept, whether it's natural selection as Darwin was promoting or various other things. But evolution was an idea that was around at Darwin's time. He found a mechanism for evolution, and that's why evolution exists. The worst thing they ever called evolution was a theory, I think, actually, and people have taken advantage of that and said, it's only a theory.
Yeah, but in science, theory has a very different meaning to what it does in colloquial speech.
That's right, it does, and
they're confusing it with hypothesis. That's what they do.
That's right, yeah, or guess.
Or idea, yeah.
Yeah, no, it is a well-established understanding of that evolution does occur, how it occurs. I think that's been discussed over the last 150 years, 170 years or whatever, and probably continue to be discussed, but no one of serious repute doubts evolution, and no one should remove it from the school curriculum.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.